Okay, today we start double and triple integrals. So, can you even see from over there?
Oh no.
So then keep sitting there. What?
Wait, could you never see like the whole areas of
Throw it away.
Okay, let's do a review of single integrals like we learned last year and what it represents. So suppose you have a region like this. Alright, let's do it in the general case. What if you have, this is A, this is B, and then you have, this is y equal f of x, y equal g of x. How do you compute the area of this region right here? What do we
We
do?
go from A to B.
No, but how do you think of it though? Yeah, I know you guys know how to write
Oh,
it.
f of x.
You think of it as a rectangle of infinitesimal width, right?
Yeah.
What is the length of the rectangle?
Yes.
No, the length of it.
Top minus bottom.
Top minus bottom,
Minus GX.
that's the length. What is the width?
EX.
Dx, because it's infinitesimally small. And then you add up all of these rectangles from A to B. Right? So this is what we learned last year in two-dimensional calculus. But now, let's think of a different way to compute this. I'm still going to do 2 dimensions and then we'll extend it to 3. So same thing, let's say you have y equal f of x on the top, y equal g of x on the bottom from A to B. Now, let's do a double integral to represent this area here. So instead of making a rectangle of infinitesimal width, we make a tiny square like that of infinitesimal dimensions. Pay attention! A square of infinitesimal length and width. So if you blow it up or zoom in, it kind of looks like this. Now it's infinitesimally small. So what do you think this is? It's a change in x, but it's delta x, but it's infinitesimally small.
Yeah.
Thank you, dx. And then here's a change in y, but delta y, but infinitesimally small.
DY.
dy. So therefore, what's the area of this infinitesimally small square? dx times dy. Everybody got that? But since now, look, you got 2 variables, you have to do 2 integrals to actually compute it. So I'm going to add it up. Now, you're going to find that the hardest part of this is coming up with the limits of integration. So when you have dx dy, that means you can integrate with respect to x first and then y. Or should I do with respect to y first and then x?
Doesn't matter.
It doesn't matter, that's right. However, in certain problems, you're going to have to do it a certain way. So in this one, I think it would be better to do it with respect to y first and then x, like that. Okay, now what are the limits going to be? So the y goes from here to here. So the limits would be g of x to f of x. You get it?
Yeah.
Because you're going to integrate with respect to y from this bottom curve to the top curve, like that. And then, after you get that, then you're going to integrate with respect to x, and what do you think the limits for that is?
AB.
Yeah, from A to B. So notice how, if you have a variable, you have to do that one before you do the constant, so you always do the constant one last. Now, some of tonight's homework, it's so easy, both of them are constant, so it's like really easy. But when you're integrating over a region, oh, how come this thing didn't come up? Then it gets a little tougher. Now, let's actually compute this integral. What is the integral? So let's do this one here first. You have to do the inner one first. What is the integral of dy? What's the antiderivative of dy?
Y.
Just y
Plus C.
plus c, but we don't have to put plus c because they're going to cancel out. Now, what happens when you plug in the top thing and the bottom thing? You're going to get f of x minus g of x. And can you see that's equivalent to this thing right here now? See, so when you do this inner integral, you get this, but then now you got to integrate that from a to b with respect to x, and that's why that and that are exactly the same. It's just a different way of thinking about it.
Wait, then why do we?
Why would you do that?
Why do we do
Why is it
that?
3 dimensions?
No, because now we're gonna extend it to 3 dimensions.
Oh.
This is just like to prepare you for what's
Wait,
coming.
we're still 2 dimensional.
Wait, what?
Ay, that's-
Well, that,
Two-dimensional.
if I ask you to compute this area, it's 2-dimensional. So like some of the problems you have, no, you don't even have, you're not, see, I didn't even, in the book, I didn't even pick the ones that are 2-dimensional. Now, let's extend this to 3 dimensions.
Today?
Yeah, right now.
Oh.
What you talking?
Can you s-
Okay, so, find the volume of the paraboloid that lies above the xy plane. And let me give you the equation of the paraboloid. Let me think. Z equals 4 minus x squared plus y squared. Do you see that's a paraboloid?
Yes.
Okay, so find the volume of the paraboloid that lies above the xy plane. In fact, I have a paraboloid right here. So like, if the xy plane was like this, then this paraboloid would be like that. Those of you on the camera look. Find the volume of this paraboloid right there. Now how the heck do you do it? Well, okay, so I'm trying to draw it. Something like that. Oh, that's ugly. I was looking at somebody's homework. They have really nice 3-dimensional drawings. I think it was Lum.
Yeah.
Yeah, she's good.
Wow, that's pretty nice. Okay, so let's suppose we're looking from the top like this. So you got this. This is the base of the solid, right? The parabolic solid. So we have a square, infinitesimal length and width. So what is the area of that thing?
dy
dy dx
dx.
or dx dy. Let's go dy dx. But then now it's a 3-dimensional thing, right? So then you gotta multiply it by the height coming up like this. And what is that height? Z. But z is equal to 4 minus x squared plus y squared. So this thing gives you a volume. So it's like here, in the xy plane you have this infinitesimal square, but then it goes up like this, and you have this prism. So what's the volume of this prism that's infinitesimally thin? Dx times dy times the height. But the height is the z coordinate of the point, which is this. See, so length times width times height, that's the volume. And we're gonna add up all of these infinitesimally thin things. Now, first of all, the base, do you see that the base is a circle? In the worksheets, we call that omega. Omega is this circle. So what is this equation of this circle in the xy plane? How do you figure out where a graph crosses the xy plane, which is z equals 0? You said z equal to 0, and you get x squared plus y squared equals 4. Yeah, it's a circle. Okay, so what kind of limits do I need to put on? So, if I'm going to integrate with respect to y first, what are you going to get?
Negative 2 and 2.
No, we're going to, no. You got to go from this curve to that curve. You always got to do the variable one first and then the constant one last. So, what's the equation of this lower half of the semicircle?
Negative.
Okay, I'll give you a hint. If you solve for y equals square root of 4 minus x squared, right? That's the upper half of the circle. What do you think the lower half of the circle is? Y equals negative 4 minus x squared. Now, since we have symmetry, you can be smart about this. So what do you think?
Oh, the x equals.
Go from the lower curve to the upper curve, or how about just go from 0 to the upper curve and times it by 2? So what do you want to do? You want to go from negative root 4 minus x squared to root 4 minus x squared? Or would you rather go 0 to root 4 minus x squared and then times it by 2?
The 2.
Yeah, because it's way easier to plug in 0 into an integral, right? And then, now after you do that, now we're going to integrate with respect to x. What are the limits on x going to be? What's the x coordinate? Negative. So we can go negative 2 to 2, or you want to go 0 to 2 and times it by 2
Wait, what?
because of symmetry. So you can either go so when you integrate with respect to y, you can go from negative root 4 minus x squared to positive root 4 minus x squared, Or would you rather just go from 0 to root 4 minus x squared and times it by 2?
It don't matter.
Yeah, it doesn't matter because you have symmetry now. If you didn't have symmetry, then you would just have to go from negative root 4 minus x squared to positive root 4 minus x squared. And then, when you integrate with respect to x, you gotta go from here to here, and that would be negative 2 to 2. Or would you rather just go 0 to 2 and times it by another 2?
Don't matter.
Yeah.
Yeah, I know, no, but I think you're gonna have an easier time plugging in 0 than negative 2. Okay, so there you go. This integral will represent the volume of the paraboloid that lies above the xy plane. Now, that's the least of your worries. Now we gotta compute this. Are we ready to compute this? Let's erase this picture here. I like that picture was easier. So 4, integral 0 to 2. So what you have to do is you have to do this inner one first. You know what? Let's just concentrate on the box right there. Now, so what do? So this is like 4 minus x squared minus y squared. You gotta integrate that with respect to y. So what's the antiderivative of this with respect to y?
No. Negative.
4y minus
Wyatt.
x squared y minus
1/3.
1/3 y cubed. Everybody got that? Because we're integrating with respect to y. All other variables are constants. Okay, everybody got, okay, from 0 to root 4 minus x squared. Okay, plug in the top. Plug in the top.
4 times
4 root 4 minus x squared minus
squared.
x squared root 4 minus x squared minus 1/3 4 minus x squared to the 3/2 power. Minus, plug in the bottom number, you get 0 minus 0 minus 0, so that's just 0. Yeah.
So if you were to do dx dy instead of dy dx, then would you take?
Okay, so if you were to integrate this with respect to x first, okay, let's do this. What is 4 minus x squared minus y squared? If you integrate it with respect to x first, then you gotta go from here to there. So then you gotta solve for x. So this would be x equals root 4 minus x squared, and then this half would be x equal negative root 4 minus y squared, sorry, y squared, it would be like that. So if you integrate it with respect to x first, you gotta go from here to here, so it would be negative root 4 minus y squared to root 4 minus y squared, and then when you integrate it with respect to y, then you would go from here to here, and that would be negative 2 to 2. And then depending on the symmetry, you can do stuff like this, yeah? I don't know, I like to integrate with respect to y first, because I don't know, it seems more natural. Okay, so now this is what this is, right, the box. Now we gotta integrate that with respect to x from 0 to 2, and then times the final answer by 4. Okay. Okay, so now you gotta know how to integrate. So we're gonna need some room here. We might have to erase the whole board. Okay, so shall we? You know what? Why don't I just give one? We're gonna break it up into 3 integrals, and then each of one of you take care of one.
Wait, but there's 4 of us.
I'll see this one.
Oh yeah. Oh yeah. Okay, who's gonna do this one? Integral of 4. Just come up with the antiderivative root. No, you know what? What the heck? Just go 0 to 2. Who's got that one? Okay, you know what? We're all gonna do it together. Okay.
4 times.
Wait, what technique would you use for this integral here?
Oh.
There's techniques.
Oh.
Oh!
Wait,
Use substitution.
No,
Integration
it's
by
fine.
parts.
Trig.
10. I mean,
Trig.
trig substitution. Partial fractions or the z substitution. The z
I
substitution.
know. Why would you use that here though?
You wouldn't. But I'm just throwing it out. The one.
Is it trig?
Yes, trig substitution. So, x equals.
Oh no, sine.
2 sine
Really?
theta.
2 sine theta. Therefore, dx is equal to 2 cosine theta d theta. You guys better be good at your integrating techniques, otherwise, wow, it's going to be bad. So, you got 4. I'm going to throw the 4 outside here. square root of 4 minus 4 sine squared theta times dx, which is 2 cosine theta d theta. And what are my new limits of integration? Park.
Pi over, or sorry. Hang on.
Plug in
Zero.
0. Get 0.
2.
And then plug
Pi
in
over
pi over 2. That's correct. Remember, when you do a substitution, the limits of integration change. So what do we got here? 8. So 8 integral 0 to pi over 2. 8. If I factor out a 4, you get 1 minus sine squared theta. So that 4 comes out as a 2. And then what is the square root of 1 minus sine squared theta? Absolute value of cosine theta. However, from 0 to pi over 2 is positive. So then actually this is a 16 now. And you get
Cosine squared theta.
cosine squared theta. Cho, what's the only way to integrate cosine squared theta?
1/2 plus cosine 2 theta.
Okay, so 1/2, 1 plus cosine 2 theta. This is just the first one, people.
Right?
So you got 8 integral from 0 to pi over 2, and then, wait, we can go right to the antiderivative right here. What's the antiderivative of 1 plus cosine 2 theta?
Theta.
Theta plus, is it just sine 2 theta?
No.
No, because I left the space for the 1/2. 0 to pi over 2. Plug in the top number. Pi over 2 plus 0 minus 0 plus 0. That's weak. 4 pi. Okay, so the first one is 4 pi.
Oh
Oh,
my
we're just
god,
in the
Mr.
next
Park.
I told you this chapter
Wait,
is
what
going to be
number?
There's
tough.
like 1 to 6 problems.
But they're very doable.
I go back to the first.
Hey, look at number 4. I'm pretty much doing number 4 for you right now.
Actually, we don't have the front line in this.
Yeah, so that one you have, it's a circle of radius 1. We're doing circle of radius 2.
Oh, so we can just like divide that to
I don't
right?
think-
No, I don't think you can do that. Okay, can I erase? I'm gonna erase this part here, because now we're gonna move to the second one. Okay, so we just figured out the first one. So this integral here, this is 4 pi. Okay, minus, now we gotta figure out that one, and then we gotta minus that one. Okay, so the next integral from 0 to 2, hopefully we can do it on one line, if not, too bad. X squared root 4 minus x squared dx. Okay, what technique am I gonna use here, Jason?
Whoa.
I mean,
Wong.
Wong.
Trig.
Okay, trig substitution. X equals 2 sine theta d theta. Dx is equal to 2 cosine theta d theta. So you got integral of x squared, so that's 4 sine squared theta times root. Come on, we already know that one already. No, we don't. 4 minus 4. Here we do. Sine squared theta times dx 2 cosine theta d theta. And what are my new limits now?
It's
0
right.
to pi over 2.
Right, you need to distribute the 4. Right. No, you see the, you know how like the 4 outside and whole integral, you didn't distribute it.
Oh no, yeah, so we're gonna
gonna-
multiply everything by 4 after. Don't worry. Don't worry. Okay, so what is this? This is 4 times 1 minus sine squared theta, radical. And so that's 2 times absolute value of cosine theta, but it's not gonna, it's because you got this. So this is what you got. 8 integral 0 to pi over 2 sine squared theta cosine theta d theta. Cho, is it 16? Oh yeah, it is 16. Cho, how do you do that integral?
Substitution.
Okay, good. Now, do I really have to do a U substitution, or can I just look at this and go, the antiderivative is 1/3 sine cubed theta?
Cosine squared theta. Or is it cosine squared theta?
Yeah.
Yeah.
Oh, shoots. Messing up. Oh, now this integral becomes tougher.
Great.
Oh. Remember we did the powers of trig functions? Remember the project we did?
Oh.
Yeah.
Project?
Not project. Okay.
Oh.
Okay, so how do you think we're gonna integrate sine squared times cosine squared? What's the only way in the whole world to integrate sine squared and cosine squared?
Oh.
1 minus cosine 2 theta all over 2. 1 plus cosine 2 theta all over 2. That's how you do it.
Okay.
So these 2's cancel with that, you get 4. And then what are you going to be left with? 1 minus cosine squared 2 theta. Which is?
1/2.
No. What is 1 minus cosine squared?
1 minus.
No.
Oh,
Pythagorean identity.
Sine.
Sine squared 2 theta. And what's the only way in the whole world to integrate sine squared 2 theta? You gotta use the identity 1 minus cosine 4 theta all over 2. This 2 cancels that 4, you get 2. Now what's the now we're ready for antiderivative. Theta minus 1/4 sine 4 theta from 0 to pi over 2. Okay, plug in the top number. Pi over 2 minus 0 minus 0 minus 0. That's weak. So that's pi.
What?
You keep looking at your iPad.
Oh.
You want me to do that? I can do that. I can just keep looking at my iPad. Okay, finally, the last one. Okay, you think we can squeeze it in right here? We better try. Integral 1/3 4 minus x squared to the 3/2 power dx from 0 to 2. Again, trig substitution. Woo! X equal 2 sine theta, dx is equal to 2 cosine theta d theta. So this becomes 1/3 integral 0 to pi over 2, come on, it's the same thing, right? 4 minus 4 sine squared theta to the 3/2 power times 2 cosine theta d theta. Okay, so again, this is 4 times 1 minus sine squared theta, which is 4 cosine squared theta. So what happens when you raise it to the 3/2 power? What are you going to get? Raise this to the 3/2 power.
Oh,
8 cosine cubed times 2 cosine. Oh, I thought we were going to end up at an odd power, but we don't. So this goes 16 over there, and so 16/3, 0 to pi over 2, cosine to the 4th theta d theta. In fact, we did that. We did that integral. Remember in the homework? So we got 16/3. Okay, how are we going to do that? The only way you can go cosine to the 4th is you got to go cosine squared squared. So 1 plus cosine 2 theta all over 2 squared. This is fun. Okay, now when you square this, it becomes a 4. That cancels into the 16, so you get 4/3 integral 0 to pi over 2. And then you're going to have 1 plus 2 cosine 2 theta plus cosine squared 2 theta. Tell me if I make a mistake. Because there's lots of places where you can make mistakes. Okay, 4/3.
How many years?
I can't believe I wrote a letter of recommendation for you.
Oh yeah, wait. Speaking of that, I guess you can do it electronically.
I already gave, I hand gave you that letter. Did you mail it in?
Yeah.
Did you put it in your packet? You gave it to Mr.
I gave it
Flynn?
to Mr. Money, yeah. So can you like type it?
Oh, you're gonna make kids
I'm
spell it out?
sorry. I'm
You
sorry.
type it out.
Why? When you have the handwritten?
Because Mr. Maniac is afraid that it's gonna like get lost in the process of.
Wait,
reading
you
all that.
handwrote that thing out? Oh.
No, I didn't handwrite it up. I just printed it out on a letter.
Okay, then.
Wait, why can't you?
Yeah, can you like?
Because he told me he needed the letter.
I'm sorry.
You suck.
Yeah, turns out you can turn it in electronically.
You
So.
should just retype it, Jay.
No, it's already typed. He just has
No,
to.
no, you should just retype it.
Oh, yeah, you're retyping yourself.
Okay,
How
before
many
I
struggles
begin
are you
again,
gonna
let me calm down a
Okay.
little.
You the man,
This
Mr.
is like
Park.
not even the
You the
first.
man.
That's
Antiderivative. Park.
I got this. Theta.
Okay, wait. The only way you can integrate this one here, though, is 1 plus cosine 4 theta over 2, correct?
Yeah.
Okay, I want you to combine it all together into just 1. Impress me. Go.
What do you mean? Oh, theta.
No.
What? Oh, 2 theta.
No.
Okay,
3/2 theta.
Why?
Because 1 plus 1/2 is 3/2. The integral of 3/2 is 3/2 theta.
sorry.
Okay, continue.
It's hard.
Okay, now this term, we're on this term.
Oh, sine theta.
Okay, and then this one over 2.
1/8 sine 4 theta.
Did Park do it correctly?
You're
Yes,
dumb.
he did. Okay, so you got 4/3, plug in the top number. 3 pi over 4 plus 0 plus 0 minus 0 plus 0 plus 0. That's weak. That's just pi. So, putting it all together, what's the final answer?
2 pi.
Times the 4. 8 pi. Bam. That's the volume of this paraboloid that lies above the xy plane.
So you're gonna do that. Oh.
Yeah, but I'm pretty sure, number 4, that's the only one where, the integrals are not gonna be this hard
Oh, there'll be some.
until you get to the test.
Oh my god.
So yes, you gotta know all your techniques of integration, believe me, they're all gonna come up. And believe me, secant cube comes up, remember I told you guys to memorize that
Oh,
one?
I forgot that one already.
I don't know anything.
It's like 1/2.
Wait, I still have the.
Yeah, it is 1/2. 1/2,
minus
Sine.
no plus.
1/2 cosine.
Oh, 1/2 secant theta
Tangent
tangent theta.
cosecant.
just believe me, every single technique we learned is gonna come up.
I forgot what
Now, I know what you're thinking, Mr. Park, there's gotta be an easy way, there is, but we haven't learned it yet.
We're gonna learn it.
Joe, are you reading ahead like you normally do?
No.
So there is an easier way of doing this integral right here. Anybody have any clue about what you would do?
Triple.
Triple.
No.
Oh.
Switch it around.
I think we're learning it tomorrow, actually. Cylindrical coordinate or polar coordinates.
Oh yeah, I forgot.
Because in the polar coordinate system,
Yeah.
do you remember x squared plus y squared equals
Z squared.
r squared?
Wait, X
So-
plus
so,
Y
like-
what?
Like, where did the original integral go?
You erased it.
Oh darn it. But wasn't there an x squared plus y squared in there?
Yeah, 4 minus x squared. Y
See, when you see that, you should be thinking, oh, polar coordinates. But we haven't gotten there yet, so tonight, this is the way you're doing it.
Wait, so like if we.
Well, if I didn't have to explain every step, I could have done it faster.
Yeah,
Oh, you could have done it faster.
Ours is like.
Not us.
No, we went over the integral review. You guys should be experts in
That
integrals.
was like a year ago.
No, beginning of the year.
That was the
Like
first,
A year ago.
that was 3 months ago.
That's a long.
Basically, it runs up to you.
Oh, 3 months, that was quick.
Okay, so tonight's, okay, let me pass out the test. Oh, you guys watching the video, corrections due tomorrow by 3 p.m.
You're kidding, right?
No, I'm not
Only one thing.